So this problem is another level surface problem with a horizontal applied force. So the first thing when you're doing these problems is you make your free body diagram. So we're going to have, it says a car is moving on a level highway. So there's the level highway, and I'll try actually to draw a car. So here's the car on the level highway. All right, so there's the car. And so it says that the mass of the car is 710 kilograms. If you can fit it right in there, then that would be great. So 710 kilograms, that's the mass of the car. Now, in order to accelerate a car, you need to have an applied force caused by the engine. So you're going to have an applied force in this direction, and we have to overcome friction. This is a little bit, I mean, the way I'm saying it is a little bit untrue because, I mean, normally it's when you're dragging something, and cars don't move that way. In fact, we need some friction between the tires and the road. But just to solve it the way we solve the other ones, you're going to do it. You'll do it this way. So this is going to be my applied force, and this is going to be friction. So the symbol for friction is italics F, and the symbol for applied force is capital F, subscript capital A. So it says the coefficient of friction is 0.3. So I'm going to put that over here, 0.3. And what acceleration will a force of 3,450 newtons produce on the car? So in this one, they're giving me the applied force. Now, some of you might say, well, how do I know that's the applied force and not the unbalanced force? Because they're just calling it the force. How do I know that? Well, anytime they start mentioning also elements of friction, that means in general that they're not giving you, if they're going to give you the unbalanced force or the net force, they're going to call it that. If they call it anything other than unbalanced or net or sum of the forces, then it's just an applied force when you're solving these problems. So if you look at the forces in the vertical direction, in the y direction, we've got the weight of the object, and we've got the normal force. So this is the weight, and that's the normal force. And what the unknown in the problem is the acceleration. So we're looking for the acceleration. So if you were doing this on a test and you had all of this on the picture, you would get 8 points because the diagram is worth that. Then from the diagram, you make your descriptive equations. Now the descriptive equations are not rules. They're not physics formulas. You are describing the picture that you just made. If you don't have a picture, you can't make descriptive equations because it has to be describing something, and the something is on the board here. So if I look at my forces in the x direction, I have two of them. One of them is to the right, and one of them is to the left. So the one to the left is negative. Think of it as if this is the origin of a graph, then I've got, that's my positive x direction, that's my positive y, that's my negative x, and that's my negative y. So we use those as far as directions. So this one's going to be positive, and that one's going to be negative. So even though I'm summing, which means adding, I'm adding a positive number with a negative number. So I'm just going to write it that way. And those two together equal the F in the formula F equals ma. They are the unbalanced force. So they are what equal ma. So those two combined are the F in the formula F equals ma. And in the y direction, we have, if we sum up the forces in the y direction, we have two forces that are in the y direction, Fn and W. That's positive and that's negative. So it's going to be Fn minus W equals, now just like the other one, it does equal ma, but this is an acceleration in the x direction because I added up forces in the x. Since this is the y direction and I combine these, they're going to give me an acceleration in the y direction. Well, my car is only going to move in the x direction. It's not going to move in the y direction, so I know that the acceleration in the y is 0, therefore ma is 0. And that's important to know because every problem, like someone said, do I have to write that? Can't I just say Fn equals W? You have to write that because in other problems, Fn will not equal W. Every problem is different. I'm trying to categorize it to make this topic as easy as possible. But there'll be other types of problems where this equation right here will be completely different. So now we just solve things in the order that they can be solved. And what's the first thing that I could solve in this problem? If I know the object's mass, what can I get? The weight. Okay, because we have the formula that W equals mg. So now, if they had told me that it was a 710 Newton car, then that would be my weight. But when they say a 710 kilogram car, I know I'm getting the mass, so I know I have to take that mass and multiply it by the acceleration due to gravity, which we write as a positive number because we've already taken care of the sign right there. So that is why, the minus here, that it's really right there. Whenever we solve these, we're just solving for like magnitudes. And our directions are all up in here. So what is 710 times 9.8? 6,958 newtons. So that is the weight. Now that we know the weight, what can we solve for? Look over to the right. Those equations over there. If I know the weight, what can I solve for? Fn, the normal force, right. So Fn equals W, which equals 6,958 newtons. It's not always going to be true. The weight does not always equal the normal force, but in this problem it does. Now that I know the normal force, what can I now solve for? Friction. So friction equals mu Fn. That's the formula. It's on your formula fact sheet. That's a formula. Again, formulas are different than descriptive equations. Formulas are universal. Everyone recognizes this is true. Everyone doesn't recognize the descriptive equations is true because they're only true for this problem. So friction equals mu Fn. So we're going to have 0.3 times 6,958 newtons. And what will that equal? $2,087. Okay, so now that we know friction, what can we solve for? I heard somebody say, what? Acceleration, because I know everything else. I know everything else. There's only 7 things total. 3 of them were on the picture that we knew. So we knew the coefficient of friction, the mass, and the applied force. So there's only 4 things left to solve for: A, W, Fn, and friction. And we just solved for W, Fn, and friction. So the only thing left to solve for is the acceleration. And I'm going to use this equation, this descriptive equation, to get the acceleration. So all I have to do is divide by the mass. So my acceleration is going to be Fa minus friction divided by the mass. And just put in those numbers and you'll have your answer. So Fa minus friction over the mass. The applied force was 3,450 newtons. Friction was 2,087 newtons, so we know it's going to accelerate, not decelerate, because that's a smaller number than the applied force. And the mass is 710 kilograms. So solving that, and I hope you get the answer that I gave for this one, which was 1.92. 1.92 meters per second squared.